All right, let's get some more algebra review. So if I want to add fractions, this is no different than when you added fractions with numbers. You can only add if they have the same denominators. So what you want to do is you want to get a least common denominator, and I can see in this case that I could make this first denominator match this one by multiplying the top. And remember, if you're multiplying by 1, so 4x and 4x, because 4x times x gives me my common denominator. So the top's going to be 16x. The bottom's going to be 4x squared. And then I leave this one alone. And notice that they have common denominators. I cannot do anything with the top because they're not like terms. So all I can do is write this over a common denominator. All right, next it says to factor the polynomial. One thing to notice that this is a perfect square because it's squared. The y is a perfect square, and 49 is a perfect square because 7 times 7. So this is that special factor, 7y, quantity squared. All right, next we're going to divide. Remember, when we divide, we flip the second fraction and multiply, plus q. So times 10p squared plus 5q divided by 6. All right, I'm going to look for things that I can factor. Looks like nothing can be factored here. 2p squared plus q. Looks like here I could factor out a 5, and that would leave me with 2p squared plus q. Remember, I told you to always look because there's probably something there. And then the 6, I could do that. Now, don't do a big no-no. Some students want to do this, and you can't, because you can only do it when the term's by itself. And so now I can write that as a 3. I can cancel this, and it leaves me with, wow, just 5 over 3. Isn't that nice? All right, next one says to subtract, simplify as possible. So they have the same denominator, so I can just simply subtract these, but you have to be careful. You're doing this really. So you need to distribute that negative on both of these values, and then all over x minus 9. So in this case, I can collect like terms, and those are the only terms that I see are alike. So 71 minus 9, so I have 7x squared minus 62x, and then minus 9 all over 9. And I want to look to see if I could factor this top. Okay, so this is still all, why'd I put a 9 there? X minus 9. I want to see if there's something I can factor. And I'm going to guess, because again, the way algebra works, I don't know that this is going to work, but I'm going to guess one of these factors are x minus 9. I'm just going to completely guess that and see if that works. Well, if I have 7x squared, then this has to be 7x, right? Because 7 times x, x squared. Well, look at this. 7 times 9 is 63. If that's a 9, this would be a 1. That's a negative, so this has to be positive, because I'm going to get 63, negative 63 plus 1, and I would get that middle, and that cancels. Always look, when you're looking for factoring, always look at the other terms that are involved, because it's highly likely that's going to be one of the factors. All right, here we're multiplying, so I'm foiling. So I'm doing the square root of 11 times the square root of 2. I'm doing plus the square root of 11 times the negative square roots of 7, plus the square root of 7 times the square root of 2, plus the square root of 7 times the negative square roots of 7. Now remember that you can multiply underneath these, since they're the same roots, and you can multiply that and get the square root of 22. You can multiply these and that's a negative, so square roots of 77. That is plus the square root of 14. And then a square root times a square root gets rid of the square root. And you should look at these to see if any of these have perfect squares in them, but I don't see that any of them do. All right, this next one, just need to remember that you can write the big square root like this as 2 square roots. The square root of 1 is 1, the square root of 64 is 8. Bam! That one was lovely. What do we got next? Going to multiply here. Now, a lot of times it might be easier to simplify one of the square roots first. You kind of have 2 ways you could do this. You could go ahead and multiply this out. So that would be what, the square root of 90, 30 times 3. And then I look at this and I say, oh, that's 9 times 10. So the square root of 9 times the square root of 10. And then that would be 3 square roots of 10, which is my answer. Or you could have looked at this first and, you know, tried to see if there was any way you could break this down. 6 times 5, 2 times 3. I don't see anything that you could have broken down first, but I'm just saying sometimes you can. So sometimes it's easier to look to see if you can simplify this first, okay, versus multiplying it out, certainly if it's a large value. All right, the next one says to find the value of the expression when x equals 3. It just simply means plug in 3 for x. So everywhere you see an x, you're plugging in a 3 all over. Everywhere you see an x, you're plugging in a 3 minus 9. So that's going to be 3 squared, which is 9. 3 times 3, 9. Plus 6, 9. Minus 18. Minus 9. Now, of course, 9 plus 9 plus 6 will give me 24. 9 minus 9, so negative 18. I see that I could divide both of these by 6 to reduce. So I'm going to get a negative 4 over 3. All right, we have something else to FOIL here, kind of like the other one we did already. The square root times the square root gives me that 11. This is going to give me a negative 6 square roots of 11, a positive 6 square roots of 11, and then 6 times negative 6, a negative 36. Those cancel. 11 minus 36 would be negative 25. And the last one, we want to add these, but they do not have common denominators. But I bet, so 5y, and then 36, 6y. I bet I could use a common denominator of 30y. So that's going to be my least common denominator, y, 5 times 6. And so to get this to a 30y, I need to multiply it by 6. And you have to make sure you're multiplying it by 1. To get this to a 30y, I'd multiply it times 5. Okay, so the first one, I have 25 times 6. That's what, 30? 12, 13, 14, 15? No, let me put my 50 there. So 25 times 6, I get 150 over 5y. And then I have my 36 times 5, so that's 30, 15, 16, 17, 18, 180. Oh, y'all are probably yelling at me. Why'd you write 5y? That should be 30y, right? All right, so 30y. This would be 30y. Now from here, you can start to do some reducing. Like probably what I would do is I would look at this and say, well, I don't know. I'm trying to think of, you know, the ways that it might be easier for you. So let's just go ahead and just add these values. If you add 150 plus 180, you get 330. Yeah, I think this will be the easier way because you'll probably see this. And I could divide both of these by 30 to reduce, because 11 times 30 gives me 330. And then if I'm dividing that by 30, all I have left is y. And that is it. Good luck on your test.